Q1G. The parabolas of equation y equals x squared plus c and y squared equals x touch. That is, meet tangentially at a single point. It follows that c equals how many? Okay, so again, graphs and equations, right? So draw a picture and we can see what's happening. So y equals x squared plus c. All right, I'm just going to assume c is 0, okay? I'm just going to draw the original version of this. So y equals x squared, normal parabola. How about y squared equals to x? Y squared equals to x, well, the x and y swap places, right? So the parabola is open to the right now instead of open up. Yeah? Okay. So, I mean, the questions want them to meet tangentially, right? But now it meets at 2 points, right? So that's why the question wants the plus c there, right? Because then the plus c is a graph transformation. So, it sort of makes this parabola, the normal parabola, go up, right? That plus c. Okay, so if you start to go up, then it eventually, it's going to look something like this, and it's going to touch here, right? So that's the intuition, right? You want some value of c there. Okay, cool. All right. So what criteria does that intersection point have to satisfy for the two curves to meet tangentially? Well, first of all, you've got to simultaneous the thing, right? First of all, simultaneous, so x squared plus c, this thing squared, equals x, right? That's the first thing, simultaneous. How about the second thing? Because there's two variables, right? There's x and c, so you need two equations to solve for two unknowns. The second equation is, that they meet tangentially, right? So at that point, the tangent is the same for both curves, yeah, for both curves. Good, okay, so that means that the gradients are the same, right? The gradients are the same. Good, okay, so dy dx, which is 2x for the first one. How about the second one? The second one is y equals to square root of x, so dy dx equals to 1 over 2 root x. Good, okay, question. Why did I not take negative square root of x? Why did I only care about positive square root of x? Well, that's because if you think of the graph I just drew, like only the top part of this parabola is going to touch the other one, right? This bottom part, no one cares, right? The bottom part is not going to touch the other parabola anyhow, right? So that's why I didn't care about the negative part. Yeah, so that's why I took positive square root of x. Good. Okay, so the next equation will be 2x equals 1 over 2 root x. Great. Okay, because the second equation does not have a c dependence, so that's very handy. So 4, what do I have? 4x to the 3 halves equals to 1, so therefore x equals a quarter to the 2/3. Cool. Happy so far? All right. So I just sub this to the first equation, and I find what c is. Yeah. So 1 over 4 over 3 plus c all squared equals 1 over 4 to the 2/3. Okay, square root both sides. 1 over 4, 4 over 3 plus c equals 1 over 4, 1/3. I'm sure this is positive, right? So I don't need to take the negative side of things. Can we see the screen? I hope yes. Let me check. Yes. So now what happens? So c is, okay, what is my c? That's minus that. Good. Okay, so let's have a look at the answers. Okay, none of them. Great. Maybe we should simplify this a bit. So let me be very careful. This is 1 over cube root of 4 minus 1 over cube root of 4 to the power 4. Okay, so same denominator, I suppose. So let's do this. 4 minus 1 over cube root 4 to the power 4. Yeah, you common denominator it, right? So, and then cube root of 4 to the power 3 is just 4. Yeah, so 1 times 4 is 4. That's why this 4 is there. 4 minus 1, which is 3. 3 over cube root of 4 to the power 4. Good, which is exactly what? That's probably one of the answers now. Let's see, exactly. All right, that's just option B. Yeah, so there we are.